This is Captain Anderson again. We're up to episode 4. Why is the Earth's temperature 59.1 degrees when there's enough carbon in the atmosphere to heat the Earth to 81.8? There's a reason for that. The reason is what I call the carbon delay. This delay is what has allowed our high-growth, energy-dense civilization to keep charging forward every year, year after year. This is what the atmosphere looked like prior to the Industrial Revolution. It took nature 50 million years to get the concentration of carbon down to that level. At that level, agriculture could evolve. Why? Because there's less carbon, less thermal energy. If there's less thermal energy, the weather calms down and becomes predictable. If the weather is predictable, our early ancestors could afford to stay in one place and experiment with agriculture. And that's how it all began. And this is what we have done. In the past 100 years, or even less than that actually, we've taken all this carbon out of the ground down here, combusted it, used the free energy to build everything you see around us, including iPhones, and we pumped it back into the atmosphere. But it takes a long time for CO2 to rise up into the troposphere. That's where it traps the most heat. So we're living on borrowed time, folks. And let me show you how. I'm only going to show you some of them. The ironic tragedy of the carbon delay. 95% of the excess heat trapped in the atmosphere by the excess carbon put there by human activity goes into the ocean. It does not heat the atmosphere around us. It does not cause heat waves or anything like that. It goes into the ocean. Once the oceans begin to warm, that does impact us indirectly. But it's a very mild response compared to what it would be like if that heat stayed in the atmosphere. But the oceans are getting warmer. The coral reefs are dying. The fish are moving north. The crabs can't make hard shells. And I just read the other day, yesterday, as a matter of fact, which would have been on the 19th of June, the oceans are changing color. They're becoming bluer in the center, in the mid-latitudes, and greener at the poles, because apparently phytoplankton, which is at the core of at the base of the marine food chain, is moving north towards the poles. Is it because the oceans are getting hotter? The scientists don't know. But I kind of reckon that's the reason they're doing it. They're moving away from the heat. 72 calories of energy are required to melt 1 gram of ice. Ice only melts once. Both poles are covered with ice. That's the Earth's air conditioning. That helps to regulate the Earth's temperature. Once you melt those poles, we're gone. I mean, we're cooked. Once you melt that first gram of ice, where does the next 72 calories of energy go? It has to go either directly into the ocean or in the atmosphere. The atmosphere heats up, it can hold more water. If it holds more water, it's more humid, and the conditions are right for cloud formation. Since there's more water, you're going to have more clouds. Clouds both block energy from coming in, but they also trap heat from coming out. Scientists did a study and they figured that the net advantage or disadvantage of clouds is that it blocks more heat than it reflects. So these are what you call self-reinforcing positive feedback loops. As they get worse, the condition that they are creating, it also gets worse. And it keeps going like this. There's really no way to shut off something like this. You know, I don't know how you do that, but we have basically kicked the Earth's ecosystem out of stasis. The pendulum is now swinging another way, and we're going to pay a price for that. It takes CO2 a long time to rise up into the troposphere. You can't tell exactly how long because you can't measure it, but it takes, according to the scientists, several decades for CO2 to go from ground level up into the troposphere where it traps the most heat. Atmospheric carbon is up 46%, but the Earth's temperature is only up 5%. Now, I've already showed you in previous episodes, there has to be a linear correlation between carbon and the Earth's temperature. It has to be. But the difference here is a factor of 10 times. So if we take the pre-industrial level of 56 and we increase that temperature by the 46% that the carbon is increased, then the Earth's ambient temperature is up to 81.6 degrees or 81.1 degrees according to this calculation. And you saw what happened in previous episodes. We can't live beyond 64. Our species will have trouble surviving when the Earth's temperature gets beyond 64. And we are now at 59.1. This is good. This is the rate of change. You've all heard, if you've made it through grade school, you've heard that the days of the dinosaurs, once they were gone, life began to change, and everything changed very slowly and was able to adapt, the plants and the animals. Well, I've heard that and I believe it, but I never understood how much that difference was, how slow the Earth cooled to get us where we are today compared to how hot we're going to make it in the future. This is the natural cooling. This is the rate of natural cooling. In 50 million years, nature removed 107 ppm carbon from the atmosphere. We figured that out. All right. That means that every year, the amount of carbon in the form of CO2 that came out of the atmosphere was 0.00000024. I don't even know what you call that number. But that's how little carbon came out of the atmosphere by nature and was converted to fossil fuels. This is how much the Earth cooled off because of the carbon coming out. This one has got one extra zero in it. It's 0.000000. There's 6 of them. So the Earth cooled incredibly slowly. That allowed all the plants and animals to change and adapt and get used to it, and so on and so forth. And it was a beautiful process. Now, how fast are we heating it up? Well, in 100 years, we've put back 2.6 parts per million per year. There's no, if you'll notice, there's no zeros there. There's 5 zeros and how quickly nature took it out, but there's not even 1 zero and how quickly we're heating it up. And by the way, I used all of the carbon in the atmosphere, not just what's being measured at Mauna Loa. We went through that, right? Mauna Loa's up here at 13,000 feet, but all the carbon that's emitted is eventually going to warm the Earth, period. There's nothing you can do about it. And look, this is how fast we're warming up, 0.031 degrees per year. This is the end of episode 4. In episode 5, I will double check some of the numbers I've used in order to determine the Earth's final temperature. And I say that because I am not a scientist. So I'm doubting myself all the time. How could this possibly be? You have to be asking yourself, how is it possible that this could be taking place and yet our leaders are walking around fat, dumb, and happy, thinking everything is going to work out all right? Ask yourself, do they really know what I know? Or is it possible they got headed in the wrong direction just like everybody else, including myself? Beginning back in August of 1988, we all got a certain mindset about what climate change was, and we focused on the weather. And that's not the problem. That's the symptoms of the problem, but that's not the cause. All right, spoiler alert. When I check these numbers, the news is not good. So I'll see you in episode 5.